here's an example dealing with Snell's law. We're told a parallel beam of light makes an angle of 30 degrees with the surface of a glass plate having a refractive index of 1.5, and we're asked what is the angle of refraction. And this is pretty much a question to show that we understand definitions. So here is the surface of my glass plate. That's supposed to be a straight line. Above it, we will assume that we have air, which has a refractive index of 1, and inside the glass plate we have a refractive index of 1.50. So let's assume we're working to 3 significant figures. So let's draw a normal to the surface. So that's a line which is perpendicular to the surface. And then think about the light. We're told light makes an angle of 30 degrees with the surface. And I'm drawing a single ray of light. If this angle is 30 degrees, then this angle must be 60 degrees, and this angle is equal to the angle of incidence, because in Snell's law the angles are related to the surface normal, not to the surface itself. So the question we're asked, well, first of all, let's show we know what will happen. The light will be bent by passing into the surface. That's supposed to be an arrowhead, and that's not a very good arrowhead. And what we're asked to compute, therefore, is this angle, the new angle to the surface normal. So we need to know Snell's law, and we can express Snell's law in a couple of different forms. So I normally remember it in the form sine theta 1 divided by sine theta 2 equals V1 over V2. However, we also know that the refractive index itself is given by n is equal to the velocity of light divided by the velocity in the particular medium. And so for any particular medium with refractive index Ni, this will be true, and therefore we could substitute for V1 and V2 in the above equation, and then we find that sine theta 1 over sine theta 2 is equal to N2 over N1, and this is normally remembered by multiplying so that we have, instead of ratios, we have N1 sine theta 1 is equal to N2 sine theta 2. But those are all valid statements of Snell's law. And in our case, we have an angle of incidence, 60 degrees, and we're asked what is the angle of refraction. So let's use the form just given, and I'm going to move up here. We'll particularize it to our case. So we have refractive index in air 1.00 times the sine of 60 degrees is equal to, and I'm going to run out of space, 1.51, which is the refractive index in glass, times, I'm just going to give myself a little space, sine theta r. Okay, and I'm just going to tie off that part of the calculation. So dividing both sides by 1.51, gives us sine theta r. So sine of theta r is equal to, just from the calculation, 0.574, and taking inverse sine, we find that theta r is equal to 34.99 degrees, which to three significant figures is 35.0 degrees. So we have calculated what we were asked to, the angle of refraction, and as always, let's make life easy for the poor person who has to mark it, and we're done.